Energy and data are the major currencies of our lives today. Over the last couple of decades, we've seen data going from being wired to becoming wireless. And this has helped democratize access to information. Can we do the same thing with energy? Can we send energy when we want, where we want, and as much as we want? And in the process, eliminate the last wire. If you could do this, the possibilities would be endless, from Earth to space. I'd like to tell you about our dream of wireless energy transfer today. It starts with something we are all familiar with, waves. So waves are very essential to our lives. You can hear this talk because of acoustic waves. You can see this talk because of a certain kind of electromagnetic waves called light. And the odds are, if you're watching it on the internet, you're using some sort of wireless connectivity that relies on wireless and RF waves. If you have two waves that have the same frequency and are going up and down, and they come together in some point in space, they will add and make a wave that's twice the height, but carries 4 times the energy. Now, if the same two waves come together at some other place in space, but one is running half a period late, they cancel, and you get very little energy, practically no energy. This is the basis for a process that has been known for a long time. It's called interference. The idea here is that if you go and sit at the edge of a pond and take both hands and put them in the water and move them up and down, each hand makes a wave. But because of the interaction of these waves, there will be some directions where you get more energy, and there are some directions that you will get less. Can we make it go only in one direction? Well, you need more hands. And they have to go perfectly synchronized. But if you do that, what happens is that most of your energy starts traveling straight down. Now, this is a remarkable thing, because if you think about each one of those little hands, each one of those little sources, they would send energy all over the place. But when they work together, the result is that the energy is going mostly in one direction. Now, if the timing was the reason for this happening, maybe we can play with it, maybe we can mess with it and see what happens. So what if each one of these sources goes a little bit after the one next to it? So in that case, what happens is that these waves start going in different directions, and you can change that direction purely by controlling timing and nothing else. Now, this makes it possible to change this direction without any mechanical movement, so it can be almost instantaneous. You can go even farther. You can think about creating a magnifying glass, a focusing system, where you can actually send the energy, most of it, close to 90% of it, in one focal point. But again, since you're controlling the timing, you can create different focal points and you can send it to them. And this is the basis for wireless energy transfer. It's as if you have an army of ants that are working in perfect synchronization. And each one of them contributes a little bit of energy, but as a whole, they send it to the right place. Now, obviously, here, timing is everything, like life and comedy. Okay. So we've taken this concept and we've built these electronic chips, integrated circuits, that each one of them generates a little bit of power, but again, as a group, they are designed to work in perfect synchronization and drive these little antennas that transmit the energy. Now, this army of ants, or army of antennas, is working together to create those focal points of energy. And what I will show you next is some examples of how that actually operates. So what you have here, for example, is a generator unit that's sending power wirelessly to the two receivers. And here the point is to see how well defined these focal points are. That LED panels basically is receiving that power and showing it. So you can see energy is going only where it needs to go and nowhere else. You can take this and put one of these generators on the ceiling of your conference room or your living room and transmit energy to various devices that need energy. Now, this generator on the ceiling is going to power a light bulb. Now, as we move the light bulb, what happens is that you see that there's no energy in the new location, but the system finds it, tracks it, and sends it to the new location. And you can see that it dynamically tracks it back and forth. You can use this to send energy to one light bulb, or to the next one, or to both of them at the same time. Now, you can use something like this, for example, to power a drone. This is a battery-less drone that's being purely powered by that generator facing up from the bottom. And it can also use the same tracking approach to track the drone. So now that we know that we can send energy wirelessly, the question is, how far can we go? Really, how far can we go? Could we put photovoltaics in space, solar panels in space, and collect that energy and send that wirelessly to Earth? This is not a new idea. The first time it was mentioned, it was in a short story, science fiction story, by Isaac Asimov from 1941. And what I love about this story is that it's about a self-conscious robot. And the human is describing this idea to the self-conscious robot, after which the robot says, "Do you expect me to believe such a far-fetched, crazy notion? What do you take me for?" The first question, almost always is asked, is that, why do you want to put your solar panels in space? Why don't you put them up in the desert and be done with it, right? Few reasons. First is that in space, you get about 8 times more energy because you don't have day and night, you don't have clouds, you don't have seasons, and you don't have the atmospheric absorption. Also, now that you have this ability to send that energy where you want and when you want dynamically, you can imagine that you have dispatchable power. On top of that, it's an always available power. This can be used for a place, for example, let's say an island hit by a hurricane where there's no power. Or a city in war zone where the power infrastructure is being constantly attacked. You can think about using this to send power to a remote village in sub-Saharan Africa where there is no infrastructure for power transmission, and that way democratize the access to energy, or send it somewhere above the Arctic Circle. So all of these things are great, but the question is, if it has been known for such a long time and it's such a great thing, why hasn't it been done so far? The main reason is that the way it has been envisioned before, they've been thinking about it as a big elephant. They've been thinking about putting big solar panels in space, collecting the power, generating a lot of energy, and then putting into a massive parabolic dish antenna and sending it to a fixed location on Earth. Sending things to space is expensive. You pay dollars, and that's plural, per gram. The other problem is that even if you could afford it, assembly of something like this in space is still beyond the capabilities that we have today. So we came up with a very different approach, where we took our generators and turned them into flexible fabric-like structures. We are utilizing the amazing power of electronics, integrated electronics, and the flexible electronics to make these very lightweight, flexible fabric-like structures that you can roll and pack. And this allows you to have these satellites packed for launch and deployed in space, where each one of these units would be about several tens of meters on the side, and then you can pack a whole bunch of them and create a constellation of them that flies in space and forms your power station to send green energy to Earth. This will be flying in formation around the Earth. Obviously, this is not the size of the planet because we're talking about a kilometer across for the whole constellation, and the planet is a little bit larger than a kilometer. We've been developing, as a proof of concept, technology demonstrator, and this is called Maple, which demonstrates the power of flexible structures and electronic circuitry to generate and transmit power in space. We integrated that with 2 other technology demonstrators for deployable structures and photovoltaics that were developed by 3 teams led by myself and 2 of my colleagues. And we integrated into a satellite that was launched recently. And the purpose of this experiment has been to demonstrate the power transfer, wireless power transfer in space. Now, that brings me back to the promise of wireless energy transfer and what it could mean for us. I believe this technology is too compelling to go away. And I believe it's bound to appear in our lives in one form or another. And that is something to look forward to. Thank you.